Alright, 12.2, geometric sequences and geometric series. Very similar moves that we're making here with arithmetic sequences and series. So let's take a look. So looking at this geometric sequence here, let's establish why it's geometric. Notice that when you look at the interval between the two, between pairs of numbers, it's not the same interval each time. So something else is going on here that wasn't the case with that was the case with arithmetic. So here notice that the pattern that we're looking at is we're dividing each number by 5, or another way of looking at it is that we're multiplying each number by 1/5. So if we keep that up, we're going to end up with a final answer over here of 2 over 625. So that would be the sixth term there. So what we're looking at here now, as opposed to a common difference, is now we're looking at a common ratio, which we're going to call R instead of D. And notice down here in this little area here, we define those terms in the sequence much the same way we define the terms in an arithmetic sequence. Notice that the number of R's that we use is always one less than the number of terms that we have. So to generate a geometric sequence, what we need to first do is find the common ratio. To do this, we don't do it the same way with arithmetic. With arithmetic we subtracted, but since the common ratio it's multiplication, what we need to do is take the second term and divide it by the one before it. So we'll take the second term and we'll divide the first one, which will make us take -1/2 and divide it by 1, and you guys know that nothing really happens here. It just turns out to be -1/2. So now that we've established that R is -1/2, we can use that R now to fill in these other terms. The next one would have to be -1 over 8. The next term would have to be a +1 over 16. And then the final term would have to be a -1 over 32. Just multiplying by 1/2 each time, a -1/2 each time. So now we can develop a general rule for this, and that general rule, to find any term in a sequence, we're going to take the first term and multiply by R raised to the n-1. Very similar to when we were dealing with arithmetic. And we had n-1 here, telling us it was that many D's that we had here. Well, this time it's telling us n-1 R's that we have here. It's always one less. So using that to attack a problem and finding the 23rd term, first thing we need to do is find R. To do that, let's take the second term, -179.2, and divide it by 256. We do that, we get -0.7. Awesome. Now let's use this and throw that into the formula for R. So substituting all the known information in here, we don't know the 23rd term, we're trying to find it. We know the first term is 256. We know that R is -0.7, and we know that n would be 23, and we subtract 1. Now remember, this 23 minus 1, just simplify that and call it 22. Now we can just throw that into the calculator and it can spit out our answer for the 23rd term, which is about 1/10. Recall at one point we were asked to work with arithmetic means in the 12.1. Now let's do it with geometric means. Notice what we can look at here is that if we were going to start at 48, we travel in this direction here, we multiply by R, here we multiply by a second R, and here we multiply by a third R. So then one way of looking at this, just like with arithmetic, is that we can take 48, multiply it by 3 R's, and we land at -750. So our next move is going to be getting R by itself. The first thing that we have to do to both sides is divide both sides by 48. So on the right side now we're sitting on -15.625. And now what we need to do here is take the cube root of 3. Taking the cube root of -15.625, or -15 5/8, we end up at our R value here of -2.5. So now what we can do with that R value of -2.5 is we can put that back into our sequence over here on the left and generate these next two terms in between. So the next term, taking 48 and multiplying it by -2.5, we get -120. Now taking the -120 and multiplying it by -2.5, we get +300. One last move that you're going to want to do to check your answer is take that 300 and multiply it by that -2.5 again, just to make sure you get -750. So now moving on to the next objective, which is looking at geometric series. The textbook chooses to have the same approach that they made with an arithmetic series. they first introduce you to what a geometric sequence is, and then they show you the geometric series is just taking those terms in the sequence and just summing them up. We can come up with a general rule for the sum of a geometric series, and it's right down here at the bottom. The sum of the first n terms of a geometric series, certainly a finite one, we're going to get into infinite ones when we get into 12.3, but a finite geometric series, we can take the first term and subtract the first term times r raised to the nth power and divide it by 1 minus r, remembering that ace of 1 is your first term and r is your common ratio. So let's put this together with one of the problems. Let's find the sum of the first 10 terms of a geometric series. The good news about this one that's a little bit different from an arithmetic series is arithmetic we needed to know the first term and the last term. But geometric series we don't need to know the last term. So let's put all this stuff together here. So the problem is asking us to find the sum of the first 10 terms, so s of 10. Notice that what we're doing here in the numerator, we're putting in the first term 16 minus 16. Now, do you see where we're getting the negative 3 from? That's right, this is coming from taking the second term, the negative 48, and then dividing it by the previous term there, 16. So negative 48 divided by 16 gives us that negative 3 right there. So now with that negative 3 for the r there, we raise that to the n power. In this case, note that the n that's here is the same n that's right there. So if this is 10, then we're going to put a 10 right there. Now notice that the denominator has the minus sign built in here. So when we build in that minus sign, and also knowing that our r here was negative 3, we get to put a second negative 3 in there, and we have two negatives there. So now looking at the numerator's result, taking 16 minus 16 times negative 3 raised to the 10th power, we get that really small negative number there, and then we divide it by 4. Remember, getting 4 from 1 minus a minus 3. And simplifying that fraction right there by taking your number and dividing it by 4, we get our final answer here, our sum, which would be negative 236,192. I mentioned this in class. This looks kind of strange, but actually it makes a lot of sense. If you notice that every even term is negative, so when we get to the 10th term, we're going to be subtracting a pretty large negative number, which kind of aligns now with the fact that we are looking at a negative sum right there. So I think we did this out just fine. Alright, so that's all of our objectives there. We were able to find the nth term of a geometric sequence, and we were able to find the sum of a geometric series.